Okay, another technique for sketching quadratics now. It will give us different information. Before we got the x and y intercepts to sketch it. This time, maybe we try to factorise it first of all, and we think factors of 10 which add up to 4. I've got choices 10 and 1, doesn't give me 4, 5 and 2, also doesn't give me 4. So this equation doesn't in fact factorise, or this function doesn't in fact factorise, so we're going to have to adopt a different method. We're going to use a technique called completing the square, and we'll see in a second what information about the curve that does give us. So what we're going to do is, we're going to try and write this as a single linear term, so similar to what we did when we were factorising, but this time we're going to square that term. In order to do that, we're going to think, well, if I were to expand this, I know I should get something which is the same equation. I've said these equations are equal, so when I expand this, I should get exactly what I have there. Regardless of what I have here, I'm always going to get, when I do x plus something squared, let's just call that b for now, I'm going to get x squared. Then, if we write this out long ways, I'd get my x times x squared. I'm also going to get x times b and b times x. So that's going to give me 2 lots of bx. Final term I'm going to get from this is b times b. Okay, so we know that it's going to be of that form. So what should this be in here? It tells me that I'm going to get 2 lots of whatever number I write here. So therefore, if I want the number 4, I need to halve the coefficient of the x term in order to get this to work. So if we just imagine if we were to expand that now, we would get x squared plus 2 lots of 2x. And then I'm going to get a plus 4. There was no plus 4 term originally. Those terms are correct. But then I've got this plus 4 that I just don't want. So what I'm going to do is, I'm going to subtract that extra 4 term. There was no plus 4 originally, so I'm going to subtract that, and then just say that there should be the original plus 10 that I wanted. So again, I minus that 4, so that these completely cancel out, and then add on the 10 that I wanted. And we can see that as those terms do indeed cancel out, this here is exactly what I wanted. So tidying this up a little bit, the completed the square form will be x plus 2 squared plus 6. So I've halved the coefficient of my x term and put it as the addition inside my squared bracket. Subtracted that term squared. Remember, I get that extra b squared out, but I don't want it, so I've subtracted it, and then I add on the 10 which I had originally. Simplifying it down, I get that form. So how has that helped us sketch? And what does it tell us about why we couldn't factorise this? Does it give us any clues as to why this particular quadratic didn't factorise? Well, let's think about our y-intercept. How do we find our y-intercept? We set x to 0. So again, if I were to just look at the bit at the end, it would appear to give me 2 different y-intercepts. But remember, we find a y-intercept by setting x to 0, so we should get 10. 0 plus 0 is 10. And in fact I do, because if x is 0 here, I get 2 squared, 4 plus 6, a y-intercept of 10. But now let's think about what happens when I try to set y to 0. If I tried to set y to 0 here, I would have something squared plus 6 equals 0. That looks innocent enough, but if we think a little bit harder, that's actually telling us that minus 6 is equal to something squared. That's an issue. We cannot, in A-level maths, have something squared which equals a negative. It can't be done. So it's actually telling us that our quadratic must turn before it reaches our x-axis. So the question now becomes, well, where did this turn? That's the obvious next question to ask. If we think about this, our clue lies in this idea of something squared, and it cannot be negative. The smallest that anything squared can be is 0. So if I've got my x plus 2 squared, the smallest value that can ever take is 0. And then I add 6. So what that tells me is that that turning point must be positioned at y equals 6. The smallest possible value of anything squared is 0, and then I add 6. So that must be my lowest possible point. But for what value of x does this occur? Well, like we said, whatever is squared here must be 0. That is 0 when x is minus 2. I've drawn that. What's wrong with my sketch? I've drawn it too quickly. I've positioned the turning point in the wrong place. You will lose a mark for that in your exam, but it's fine. If you realise you've made a mistake, cross it out and correct it. Now our turning point is on the right side of the axis, and we understand why we couldn't factorise it. In fact, there are no solutions to y equals 0. This quadratic can never equal 0.